review from last night. All right, which ones do we need to see? Y'all got to tell them. Who? 59. What else? Who? 57. Any others? 49. Others? Any others? Going. Anybody? Yes. Yep. What? 43. I could. Yeah, if you want to. For real? Going. Okay, here we go. 39, let's look at this. I need a textbook. No, you keep yours.
Your catalog.
Your catalog. Hey, I don't want your catalog. You save that catalog as a ray. As a ray. That's the funniest thing. Aren't you glad you told me? All right. Oh, and it's on the recording too. So even better. Okay, here we go. Oh, give me somebody's book. So I can do it. Just so I can see the problems. Page 534, 543. All right. Oh, I can't see either. Someone's holding up my nose. 39, here we go. Oh, this is a good one. 6x squared minus 5x minus 6. This is the thing that I love, that I discovered last semester. And I know Ms. Wallace teaches it. I think Ms. Harrell knows it now, so here we go. You've got to try to, we know we have to unfoil this. But do the trial and error thing, it works. It absolutely works. And I know Gammons teaches the trial and error, and that's totally cool, because it works. But you have to be persistent, and you have to keep working and keep working and keep working until you get it, okay? But this is the most wonderful thing I've ever learned. That's a lie. It's one of the most wonderful things I've ever learned in fact. I'm going to take the first coefficient of the leading term, and I'm going to take the last term, the constant, I'm going to multiply them together. Watch what I do. I'm going to copy the x squared minus 5x. And what's 6 times negative 6? Negative 36. Now I can unfoil that. That one's easy to do, right? So here we go, 2 binomial factors. X and x. Now here we go, because I say the same thing over and over again. 2 factors of 36, but when I subtract them, they give me 5. 9 and 4. I go 9 and 4, and then I go on the side, same or different, you go different, and then you go, all right, which one has to be negative? The 9 does. I can't think of negative 9. I have to put numbers in, then I'm done with. Am I done? No. Because I can't forget about the 6 up here. I'm going to take that number and I'm going to throw it under both of those. And now we're going to reduce or simplify, whichever we have to do. So 9/6 becomes what? 3/2, right? Because I want to keep it as an improper fraction. And 4/6, it's hard to say, becomes what? 2/3. Now, do y'all see how I'm kind of writing those fractions jacked up like that? I'm doing that to remind myself that I have to take this number, that denominator, and I have to throw it in front. So now my 2 binomial factors are 2x, put my 2 in front, minus 3, times what? Y'all talk to me. 3x plus 2. 3x plus 2. That makes factoring with that leading coefficient so much easier. Oh, Because I can reduce fractions all day long. Okay? What do you think? Don't you wish you were been taught that in Algebra 1 instead of that trial and error stuff? I was taught trial and error, and up until last fall, 3 months ago, I taught trial and error. And the kids were like, no, no, no. And I finally lost my mind and said, oh, we got to find something else. Found it on the internet. What do you think about that? Questions? Fossil or diffusive? See? Okay. I don't know. I just know fossil or diffusive. 40. We got 39. Let's go to 43. Okay? Or what's the 43? Trinomial, so you have to know you've got to unfoil it. So it's 2 binomial factors. What goes in the first spot? What's r squared? How do we get r squared? R times r. And how am I going to get? I need 2 factors of 9s that when you add give you 6, or just 9. What 2 factors of 9 give you 6? 3 and 3. You got to throw the s on the end. Signs same or different? Same. They're both going to be minuses. What's the best way to write this problem? Quantity squared. If you ask me to do this problem and you're not writing it down, just know that I love you. And you're awesome. Any questions? I love Paul. Don't you wish you could Paul's real life? What was the next one you needed to say? I love y'all. Seriously, I do. 43's done. Go to 49. 49, 49, 49. 49. 49. Here we go. Oh, yeah, this was good. This was really good. Quantity squared minus. Oh, y'all, this was a good one. How many of you were like, what in the world? Yeah, this was tough. But if you know what you're doing, that's not. If you know what you're looking at, this is a total, you can totally do this problem. Okay? First of all, look in the middle. It's a difference of what? It's a difference of squares. Now these squares look weird because it doesn't look like this difference of squares, right? This is an Algebra 1 difference of squares. Welcome to trigonometry. Geometry and all that. This is trig difference of squares, okay? So you know, how do we break this down? How do we break down x squared minus 4? Anybody? Come on. X minus 2, x plus 2, right? So what are we going to do to something when it's a quantity squared? We're going to have big old brackets. Or I have to use brackets. Because I have to. Now, how did we get, I'll put this up here. How did we get our x's? What did we get our x's? We took the square root. So folks, if we have a quantity squared, and I want to take the square root of the quantity squared. What is the square root of the quantity a plus b quantity squared? It's that quantity. It's a plus b. A plus b. A plus b. And then we've got to do the same thing with the a minus b, because what did we do with the 4? We took the square root of 4 and we got 2 and 2, correct? So what's the square root of the quantity a minus b? A minus B. And we're going to put those. And what are my signs going to be for each bracketed binomial term? Minus and plus, correct? Is everybody with me? Yes or no? Your silence tells me everything. What do we have to do? Look at the first bracket. I've got minus the quantity, folks. Don't I need to distribute that -1 that's not there, but we know that it is? Don't we need to distribute that? Okay, watch what I'm going to get. A plus B minus A plus B. Everybody with me on that? What about the next bracketed term, expression, whatever we want to call it? What do we get? And I show every step. I show every step, and it's going to get on some of your nerves. Sorry. Love you anyway. But I show every single step. Okay? What did I get? A plus B plus A minus B. Now some of you are thinking, what? Why am I in this class? Why don't I have this going on? Why do I go in this class? That's what you're like, right? Where should I show up? I'm showing up. Where are you guys? Don't look at me. What's on the What am I going to do, y'all? Come on, first combine like terms. Combine like terms. Okay? A minus A, they cancel out what? B plus B is what? 2B. That just really broke out like that? Seriously? What's up with the second bracketed expression? What happens? Combine like terms again, but the B's cancel out this time. Really? We start with this, and then we get down to this. Are you kidding me? What the crap? What's 2B times 2A? 4AB? Is that really the answer? Yes. Yep, it's really the answer. Can you believe that? Would you ever have thought that you would have got that for your answer to what we started with? I wouldn't have. Kind of cool, though. Could you have solved this differently? You could have, I'm not going to. Give that extra credit. I won't accept it. Questions on that at all? All right. Let's look at this one. Oh, this is a good one. This is a really good one. This is a fun one. Guys, this is a grouping. With different squares. This is a good one. This is definitely a trig factoring problem, okay? What do I have in common? What's written right now? Both sides. I've got the quantity x squared minus 1 common to both sides, the left and the right, correct? So if you can think grouping, and Wickstrom always taught this, I love the way he taught this, but you take that quantity and you throw it out front. So now I've got x squared minus 1. What's left over? Squared minus 9. X squared minus 9. So now we just grouped it. Now don't we have two difference of squares, y'all? Yeah. How do you factor x squared minus 1, everybody? And how do you factor x squared minus 9? X minus 3 and x plus 3. Is that all I can do? Uh-huh. correct? What is the GCF of this thing? We have one x minus 1 quantity. Do you have anything else? Or is it x plus 2? X plus 2, okay. You guys agree? So that's my GCF. Do I have to multiply any x minus 1s to the first term? If it's out here, do I have to put it in here? No. What am I going to put at my first spot here? 1 x plus 2 quantity. Now look at that. Does that make sense? Give me something. Yes, I get it. No, Miss Perry, I don't know what the crap is going on. Okay. Minus. Do I need another quantity of x minus 1? Yep. Do I need another x plus 2? No. Is everybody with me? All right, here we go. Keep bringing down those factors. X minus 1 times x plus 2. What do I have to do inside this stuff right here? What do I do, guys? Come on now. I got to get rid of this subtraction because I have minus the quantity, right? So I'm actually going to distribute that -1 that's not there, but we know it is. What's it just do? Let it just change the signs. So we get x plus 2 minus x plus 1. Is that right? Guys, don't ever let me make a mistake. You know, because I've taught so many of you, if I make a mistake on the board, please tell me. And don't be ugly about it, but just say Miss Perry. Just tell me. Makes me better. What am I going to do with that last set of parentheses? Combine like terms, thank you. Really? I'm not going to call at all. What happens to my x's? They drop out. I cancel each other out. 2 plus 1 is 3. Can I leave the 3 at the end like that? I can. It's still going to be correct. But it looks better to go where? It looks better to move it to the front. And remember, it said to factor it completely. So it is. Questions? Comments? Read your points. You're right. All right. GCF. What are we saying, Tom? Wow, we have a lot of the 4. What else? How many y plus 2s? 3 of them. Isn't this insane? What's left? Hold up. 1. 1. Right? Yes. Yes. 2 syllables. No, what's sometimes this thing times 1 is this thing, right? Plus, how many y's? 1 y. And how many y plus 2? 1 quantity. Okay. How do we do this? What do we do? What do we do? Aren't you glad I'm home before 4 o'clock? Seriously, what do I do? Yes, ma'am. Distribute the y here? Yes, ma'am. Absolutely. Am I going to leave that stuff in the front? Leave it alone. Okay? Watch what we end up with. 1 plus y squared plus 2y. Correct? Everybody with me? What's wrong with that trinomial? Because it kind of makes me crazy. It's out of order. Yes. got to put it in what order? Descending order. So when, how will I write it? Am I done? Why? Let's factor the trinomial. Do we have to write all this stuff over again? Yes, we do. Fun stuff. Folks, what goes in the first box? Y and Y. What goes in the second box? 1 and 1. Are my signs same or different? Same. They're both going to be pluses. Can I rewrite x plus 1 a better way? Yes. How? Quantity squared. How about the minus? What do you think? What do you think? All right, here we go. Very quick examples and we're moving on, okay? Because we have to. Factoring trinomials, the unfolding guys, you need to see another example of those. Anybody? Want to see another one? Yes, that was a yes. All right, here we go. Did I date the earlier? I dated them, right? Okay. Factoring trinomials, this new way. All the kids do it. All right, here we go. Let's do x. I'll probably lose one. Let's do x squared plus 7x minus 4. Okay. I do not want to trial and error anything anymore because this new way is the coolest thing I've ever seen. So here we go. Somebody taught me through this because this is when you learn it. It's when you have to tell it to someone else. Somebody taught me through it. 2 and the negative 4, okay? Done. Multiply. What do I write now? Excellent. How'd you get the negative 8? 2 and the negative 4. Keep going. Incorrect. How?
Wait.
Okay. Go. Go, Christian. Your turn. Whoa! Should have looked better. Sorry. Do I make 2 binomial factors? Yes, okay. All right, so how do I take care of that x squared? What times what's x squared? X and x. There we go. And then what 2 factors of 8 can we subtract to give us 7? 8 and 1, right? And my signs are going to be different. Which one has to be plus? You said 8, right? Okay. I don't know how y'all do plus 8 minus 1. I cannot do it that way. Y'all are smarter than me. Now what? Somebody else go. Because that's not my answer, is it? What do I have to do? Bring back out the negative 8? No? That's 2. Oh, we got to remember that too. Here we go. And I always go with my arrow. So it keeps me remembering what to do. So I'm going to divide the 2 into 8. And I'm also going to divide the 2 into what? Negative 1. And I write it messed up like that on purpose. What is 8 divided by 2? Which gives us x plus 4. What about the negative 1/2 thing? Say it again. Does it stay the same? Because we've never, think about it. In Algebra 1, did you ever have a fraction? How do I rewrite that 1/2? X minus 1/2. How do I rewrite it? No, not 2x. Throw that denominator in front of that variable. Good try, though, Austin. 2xy plus 1. And now we're done. Okay? Carmen? No, because I don't put the 2 here, because I can divide it. Remember, if it can be reduced, we reduce or simplify. Whichever the way it works out. What did we do to the first one? We simplified 8 divided by 2. What did I do to the second one? Well, we didn't really reduce it, but didn't we do that on the homework problem? Didn't 6/4 have to become 3/2? I think on the problem we did for homework. Does that make sense? Does that help? That's the coolest thing I've ever. Oh, it's so cool. I'm talking about how cool it is. Seriously, I won't say it. I promise. All right, so let's go over a grouping problem. How do you know when you have to group? When we're factoring? What's the clue? It almost always has 4 terms. You look for 4 somethings. Okay, in our homework we had some quantities. Sometimes it's just going to be plain old numbers. Let's look at this one. And this is taking you back to like algebra 2 grouping problems. 10ax minus 2xy minus 15ab plus 3by. Separate them into 5 numbers. I'm going to factor out the GCFs of the first 2 and the last 2. I am going to separate them. I'm going to separate them in just a second. Okay? Take the first 2 terms. What's the GCF of the first 2 terms? 2x. 2x times what gives you 10ax? 5a minus 2x times what gives you negative 2xy. Right on. Now we're going to worry about this, the last 2 terms. What's the GCF of negative 15ab plus 3by? Is it going to be a negative 3 or a positive 3? We kind of have to just see what it's going to. We want to end up having a negative in our quantity, okay? So, in order for me to do that, if I throw a negative 3 what? Negative 3b out front, then a negative times a positive what will give me negative 15ab? 5a. And then a negative 3b times a what gives me positive 3by? Negative. That's right. Do I have a matching quantity now? Yes. Here it is. What do I do with those? It's kind of like a GCF. What's the GCF of this? Well, that quantity 5a minus 1. Throw it out front, and what's left over, y'all? 2x minus 3b. We can't do anything else. Questions? Are you cool with that? No questions at all? Nothing like it. We work all the time in this class, and we never have any fun. Here we go. Appendix 3. We're still in Appendix 3. We're reviewing all this algebra 2 stuff, okay? And we're going over rational expressions. Did anybody have to look at the website last night? Thanks, y'all. Appreciate that. Okay, here's the thing about the website. I'm putting a hard copy of your notes and the recording of the lecture on the website. So if you need to sit and watch, I'm not that type person, but I know that some folks have to just sit and absorb. If you're that type person, as much as it pains me, because it drives me crazy, I will let you print off my notes. But then that's on you. I can't print it for you, okay? Some people just need to do that. I'm not like that, but I get it, okay? And I'm all right with that. So my website's full. I'm just like, having a website. It's over there. Check it. It is. So, here we go. Rational expressions. What are rational expressions? Rational expressions. Any number that can be written as a fraction. Fractions, 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 fractions. We're going to go over them 500 more times than you've ever been over them in your life. Okay? I love fractions. Y'all don't like them, you will learn to love them. You got to remember about a fraction, though, the denominator can never be equal to what? Cannot be equal to 0. Why? If it is, what happens? That it's an undefined number, an undefined term. And you may want to write that down. Okay? So what if you had to simplify a bunch of rational expressions? Am I going too fast, guys? Okay. So let's simplify. Let's look at this first one. Very basic. C plus 5 over the quantity 2C plus 10. Folks, how do you simplify a rational expression? What's the first thing you have to do? Well, we do have to cancel things out. Do we do that first, though? Ooh. What about the GCF? Keep talking. What's that part of? You take out the GCF, you are trying to do what to the expression? Factor. We got a factor? All right. So simplify. You factor. This is very important. And you cancel out factors. This is the important part. Not terms. Cancel out factors and not terms. So, I heard you say earlier, just a minute ago, you said GCF. What GCF? In the bottom. Is the numerator simplified? Yeah, I mean, it wouldn't do me any good to take out a 1 for the GCF, would it? No. So let's take C plus 5 is equal to 2 times the quantity what? C plus 5. Everybody cool with that? Now what do I do? That's an arrow. Cancel out the C plus 5. Does that mean, and this is the part I want you to pay very close attention to, am I going to cancel out the C with the C? No, because that's trying to cancel out terms. I cannot do that. I'm going to cancel out C plus 5, C plus 5. What's that leave in the top? It's not a 0. Why? Because C plus 5 times 1 is C plus 5. That's that understood 1. What's on the bottom? 2. For real, my answer's 1/2. Seriously? Yes, it is. Do you remember that? Does that seem okay? Does it seem pretty easy? That's about as basic as it's going to get. Aren't you glad? I told you that. Questions at all? Let's move on. So here's another one. Remember factor and then cancel out factors. Here's a to the fourth minus 3a cubed over 2a cubed minus 6a squared. Tell you what I want you to do. I want you to do that problem, and then I want you to do this one with somebody sitting beside you, in front of you, behind you. You can group that together close. If you're closest, vicinity to each other. Here's the other one. You guys do those two together. I'll give you just a few minutes. Fun times. Fun times. What's the first thing you factor out always? GCF. What's the GCF of this first numerator in example 2? A cubed. A cubed times the quantity of a minus 3. That's very good. What about the denominator? What do I factor out now, guys? 2a squared times the quantity what? A minus 3. What do I do now? Cancel out what? My a minus 3's. I got to cancel the factors. What about my a's? Can I cancel out something with the a cubed and the a squared? Yeah. Can I do it here in this step? Believe it or not, I'm going to. If I cancel out my a squared here, how many does that leave on top? 1. So what is my final answer? A over 2, correct? How many of you got a over 2? Hands up. Rock on, y'all. Very good. What about the third? Do you have any questions at all on example 2? What about example 3? 3x squared plus 10x plus 3 over 3x plus 1. What do we have to do to the numerator? We have to factor that. Okay? That's got a leading coefficient, so I've got to throw it over here to the side. And I've got to factor that. Isn't that multiplying thing? Okay? X squared plus 10x plus 9. Give me two factors of 9 that when I add, give me 10. 9 and 1. Both sides are going to be the same. Both going to be pluses. Don't forget to come back and divide by 3. And I get x plus 3 and 3x plus 1, correct? That was fast. Is that my numerator simplified though? Yes. Do you see how I factored it? Did you get x plus 3 times the quantity 3x plus 1 though? You've had 3x plus 1 and then you had x plus 3 without doing all this?
I didn't do that. Put the plus 1 on top.
No.
It works.
Same answer. Did you get x plus 3 in the numerator?
Yes.
Did you factor by trial and error in the numerator? Not really. You just figured that it was going to cancel out the 3x plus 1. Okay. This ain't Vegas, and you can't always do that. Just throwing that out there, guys. You gotta know how it's good. Okay? Can I cancel out the 3x plus 1s? Of course. What am I left with? X plus 3. You win $1 million. How many of you got that? Hands up. Rock on, y'all. Questions at all? No? Is it always going to work that way, sunshine? No, it won't always work out that way. All right, here's another one. Ooh. This is not an example. Kind of changing gears a little bit. We're going to multiply. Do I want to do? No, you know what? We're going to stop right here. I'm going to give you your homework assignment. Is that going to break your heart? No. I don't.